Hey, Calc Kids, I'm home today with my kids, so I am recording this second half of section 5.5 for you. I have a sleeping little boy here, so if you can hear him snoring, that's what that is. Malia, turn that down, please. Okay, so we're on the back side on example 3, and we have ABC to do, and this just kind of illustrates how the same function with just a little bit of change can change the horizontal asymptote. So I want you to look at like the difference between each one of these functions. The only thing that's changing is this x by the 2x. Malia, turn it down. The x squared and an x to the third power. That's all that's changing. It's getting a little bit, as it's getting one higher power each time. Okay, and I know that you guys have like 2 homework problems that are like that, where you have the same problem. It was like f of x is some function, whatever, and then it says g of x equals like f of x divided by x, and then this part B was f of x divided by x squared, and f of x divided by x to the third power, stuff like that. And so what it's just doing is it's saying, take this stuff, put it over top of x, see what the asymptote is. Take that same stuff, put it over x squared, see what the asymptote is. Take that stuff, put it over x to the third power, see what the asymptote is. Okay, so we're going to look at each one of these, and we're going to use these guidelines 1, 2, and 3. So looking at the degree, what n and m are. Okay, so in part A, n, if you're looking at the degree of the numerator is just 1, and m is 2. And the rule for n less than m is that y equals 0 is the horizontal asymptote. So when we're trying to find the limit, we would say that limit is equal to 0. Okay, so going both right and left, this must have it has a horizontal asymptote here, and it looks something like this. So as x goes toward infinity, it's saying as x goes forever to the right, what y coordinate is it approaching? It's approaching that y coordinate of 0, because it's flattening out. Okay, this one here, you have n is equal to m, and you have both of them are a good degree of 2. So in that case, you look at the leading coefficients. So your horizontal asymptote would be at 2/3. So that means your limit is 2/3. Okay, and what that means is on the graph, instead of it being at 0, it's up here at about 2/3, right there like that. And as x goes to, oh, that's really terrible. As x goes to infinity, meaning as x goes forever to the right, it's flattening out at that 0, at that 2/3 value. Okay, and then part C, n is greater than m. N is 3, m is 2. So we're no longer looking at the leading coefficients. It's not 0. There is none for a horizontal asymptote, which means that the limit does not exist in this case. Does not exist for a limit. Okay, it's not approaching one single number. In fact, what's happening to this thing it's probably looking something like this. I said that if it doesn't have a horizontal asymptote, usually it has a slant asymptote. So it probably has a slant asymptote and then a vertical asymptote, and then it looks something like, I don't know, this is a function maybe. Okay, something of that nature. So it's saying as x goes toward infinity, which would be this little piece right here. That's x going to the right forever and ever and ever, but it's continuing to go up and up and up forever, but it's not approaching one particular y value. That's why the limit does not exist. So technically, the limit is infinity because it's approaching an infinite value. As x goes to the right, it's approaching an infinite value up. But since infinity is not a physical number, the limit does not exist. So that's how we kind of tackle those, okay? So there's the rules, follow those again. This one, though, I want to talk about him for just a second. If you look at this function, and we look at the degree of the numerator, degree of the denominator, okay? The fact that there is a square root in there just kind of screws things up. So we can figure out n. N is 1, that's the degree of the numerator, but the degree of the denominator, it's really x to the second power, but it's the square root of that. So if you just look at the x's and like say the square root of x squared, because that's what the bottom is saying, if we ignore the 2 for right now, if we just look at the degree, the square root of x squared would mean that the degree for m would be 1. if that makes any sense, okay? So you look at really what the square root of that x coordinate value is, and this 2 that's in here would actually become a 1 because you're taking the square root, okay? The square root of x squared is x to the first power. So your n and m are both 1, and then you look at the leading coefficients. So I look at these numbers out in front, okay? So 3 is going to be your top number, but that 2 stays under the square root of 2. So your horizontal asymptote is at 3 over 2, and since you're doing square root, technically you have both plus and minus, and it's 3 over negative square root of 2 also. And what that looks like on the graph is one of these guys. So he's a horizontal asymptote there, horizontal asymptote here. There is, as x goes to the right, it's approaching that horizontal asymptote of let's see, positive 3 over the square root of 2, which is a little bit more than 1. It's like right above 1. No, it's right above 2. I'm sorry, right above 2. And then this same thing for the 3 over the negative square root of 2. It's right below negative 2. Now, on this one, you kind of have to consider the graph, because we're saying as x goes toward infinity, which is going to the right side, and in that case, even though there's 2 horizontal asymptotes, we would only be looking at this top one, because it would be x going to the left that we would look at this bottom one, okay? So, like looking at x's that are greater than 0, they're approaching a limit of 3 over the positive square root of 2. X's that are less than 0 are approaching 3 over negative square root of 2. And so the limit for this one, since we're looking at x going to the right side, we're looking at positive 3 over the square root of 2, okay? So that might, you kind of have to take the graph into consideration, since there's 2 horizontal asymptotes, okay? This last one, oxygen level in a pond. Suppose that f of t measures the level of oxygen in a pond, where f of t equals 1 is the normal unpolluted level at the time t is measured in weeks. So at week 0, that's before any organic waste is dumped into the pond. Organic waste is dumped in then, and then as the waste material oxidizes, the level of oxygen in the pond is going to go down, and then it's going to go back up again. So it starts out with, complete 100% oxygen in the pond. Oxygen levels, they're represented as percentages, but as decimals. So this would technically be 100%. This would be only 25% oxygen in the pond, etc., looking like that, okay? So you can kind of see from the graph that what's happening is they're dumping this waste into the pond, and then it bumps all the way down to only like 50% oxygen, okay? And then it's going to slowly come back up, because that oxygen, or the waste materials in the pond, are going to slowly break down, and then that oxygen is going to be restored. So what percent of the normal level of oxygen exists in the pond after 1 week? So since our equation is represented in weeks, we go ahead and just plug 1 in there. So 1 squared minus 1 plus 1 over 1 squared plus 1, okay? 1 squared is 1, minus 1, those go away. We have 1 over, and the bottom number is 2, which is 0.5. And I'm sure Win is like screaming at the thing right now saying, well, just look at the dang graph, because it's right here, right? 1 comma 0.5. If you plug it into the equation, though, that's that confirms it, okay? So after 1 week, I'm going to list that off over here. 1 week is at 50% oxygen, okay? After 2 weeks, we would plug 2 in, 4t in here. But we'll just cheat and look at the graph. It is at 60% oxygen, so it's on the rebound. It's on its way back up. And then what is the limit approaching as t approaches infinity? So as we keep going on, 10 weeks, 11 weeks, 12 weeks, at 10 weeks it's at 90% oxygen again, but 11 weeks, 12 weeks, what will it approach? And it's going to approach that horizontal asymptote, which is at 100%. You can see by looking at this equation here that if you look at n and m, n is 2, m is 2. Since they're both the same, we look at the leading coefficients, which are the numbers in front. And since there's no numbers, it's 1 over 1. So the horizontal asymptote is 1, which means our limit is 1. which means 100%. So it is slowly trying to bounce back up to that 100%. Now, since this is a horizontal asymptote, what this is saying here is that it will never actually reach fully 100% oxygen again, okay, which is kind of weird to think about. Even the further out and out and out, let's see, the further out and out and out this goes, the closer it will get back up to 100%. But since there's that dotted line there, it will never actually reach fully 100% oxygen ever, ever, ever again. Okay, it's kind of hard to wrap your brain around, but it will never reach fully 100% oxygen ever again. It might get 99.9999999, but it will never be 100% again. Okay. All right, that's all I have for you. Use that information to do the stuff on the homework. Try to get through the story problems, and I will hopefully see you tomorrow.